Hello. Now this question pertains to inversion of amines. Now when we say inversion of amine, it is basically inversion of their configuration, right? And the energy barrier is so low that the tertiary amine of one type, let us say this one, readily undergo inversion and convert into the other configuration. So that is the inversion of configuration in amines. And because of rapid flipping, this nitrogen, even though it is chiral, is not optically active. Now the question over here says that several factors, steric electronic orbital interaction, can affect the inversion barrier in the given data which is correctly placed. So we need to understand over here, then when it is inverting from this state 1 to state 2, then there would come a flat intermediate, because it has to go through the flat or the intermediate which is more electronegative. Just like it is sp3 hybridized, so it will have to overcome this flat intermediate and bend on the other side, right? So as the bond angle increases, the electronegativity increases. So this would be, the intermediate would be much more electronegative state, right? So now, given this fact, let us see what is the data given for every competing molecules, and let us see in which it is very easier to invert. Delta G over here would represent the barrier in energy towards rotation. So if the rotation is, if inversion of configuration is easy, then delta G value should be less. So in the first one, we can see we have two molecules over here, this one and this one. So what we see over here is this isopropyl is bulkier than methyl. So if it is bulkier than methyl, in the substrate there would be much more repulsion. So it is pushing that to move towards the intermediate flat state. Why? Because the steric crowding would be relieved, right? So isopropyl group, because of its crowded nature, pushes the molecule to the other side, or to achieve the intermediate flat state, because in that case they would be far apart, and therefore inversion is more likely to happen in isopropyl containing substrate than other one. So here this delta G should be less, and therefore A is correct. Now what about the second one? Now we know that this three-membered ring is highly strained because of the constraint in the bond angle of 60 degrees. Now an intermediate is a flat state where the bond angle requirement is 120. So angular strain already was much in the substrate, and then the intermediate state required that it should have angle of 120. So that bond strain is actually increasing. So better would be the right one, where you have a 5-membered ring, and the angular strain which arises can be accommodated over a larger chain. Therefore this delta G should be less. So B is also correct. What about the third one? Now here we will have to see what factor, positive electron releasing factor or electron withdrawing factor, is going to stabilize the intermediate state. The intermediate state, as I have said, is more electronegative. Now what happens is, as nitrogen goes from sp3 to sp2, the intermediate state electronegativity of the nitrogen increases. Now what happens? Electronegative chlorine, it pulls electron density away from nitrogen, whereas methyl is going to increase the electron density. So what chlorine does is, it creates a deficient electron, it creates a deficient nitrogen, which is deficient in electron. So therefore the intermediate state is destabilized, right, because of the electron pulling behavior, right? So if the transition state is destabilized, the reactivity is less, and therefore the barrier towards this inversion would be more. So also for C, delta G of the right hand side molecule should be more. So we can see that data is correct for all of them, and therefore answer for this question would be D.